Okay, so this question is from CSC 2017. So let's look at this question. So here C1, Cn are the scalars, and we have given that C1 times some column vector. So this A I represents the column vector in R 11 dimension. So this vector belongs to some 11 some space that has the dimension 11, right? And what this ensures that the linear combination of this column vector is 0. That means it ensures that there exists a combination that is producing the 0 vector. That means if we are writing the system of equation Ax is equals to b, and the columns of A are these vectors, right? So, and what we are doing is that given this information, we are sure that that all these columns are not linearly independent; they are dependent, because this statement ensures that there exists a C that if you take the linear combination, that is going to produce the 0. So all the columns are not linearly independent; they are dependent. And here in the system we have given B, and also B have given this. What does it mean? That B is a vector and it is a sum of the columns, right? It is a sum of columns. That means B will be in the column space of this A. Now what we have been asked, that set of equation has the unique solution, no solution, infinite many solution, finite many solution. So you see that this B is in the column space of this vector A, right? So there would exist many possible combination that is going to produce this B, because B is in the column space of this A, right? So we will have for this infinite many solutions. The correct answer for this infinite. Thank you. So this question is from CSIT 2017. So we have given this characteristic polynomial of matrix M 3 by 3, and all the elements are real, and we have given this characteristic polynomial, and here A belongs to some real number, and we have given this one eigenvalue. We have to find the largest among the absolute value of the eigenvalue of M. So we will have to look at the which eigenvalue is the largest, or we will have to take care of this also that we should take consideration this absolute value, right? So how we can do that? It's an easy question. So first of all, we will have to find this A, and using this lambda 1 we can find this A. So that would be 8 minus 16 plus 2A plus 30 is equal to 0. So from here A we get A is equal to minus 11, right? Now what you can do, you can put the A and you can write the characteristic equation as this, right? And now we know one of the eigenvalues 2, so this cubic equation can be factored as lambda minus 2 and lambda square, so that will produce this lambda cube minus 2 lambda, so that will produce this 2 lambda, that means 4 lambda, and 2 minus 2 lambda square, and that will be plus 4 lambda, right? And again we need to have, so here it is 4 lambda square, right? So lambda square, oh, okay, so here minus 2 lambda square, that will give the 4 lambda square, and now here we need minus 15. So okay, so that will so this multiplication will give this. So this is a factor of this cubic equation, right? And from here we can say that lambda square minus 2 lambda minus 15 is equal to 0. Now we can factor it out further. So lambda square minus 5 lambda minus plus 3 lambda minus 15 is equal to 0. And from here we will get lambda lambda minus 5 plus 3 into lambda minus 5 is equal to 0. So lambda is equal to 5 and lambda is equal to minus 3, and one lambda is given, that is 2. So largest among them, and you will have to take the absolute value, and largest among them is the 5. So correct answer for this is 5. Okay, let's look at this question. This question is again from 2017 CSIT. We have given this matrix P, this matrix Q. What we have been asked that what is the rank of P plus Q. So we have to find the rank of P plus Q. What you can do, you can simply add up P plus Q component wise. So we will add up this component. So that is 0, and minus 2, that will be minus 1, and minus 1 that will be minus 2, and 2 plus 6 8, and 12 minus 3 is 9, and 6 plus 4 is 10, 3 plus 5 is 8, 10 minus 2 is 8, 5 plus 3 is 8. Now we can do the elimination. So you see that this is a pivot, that is 0. So 0 can't be pivot. So what we can do, we can bring this row to here and bring this row to here. There is no harm doing that. So we can do 8 8 8, third row to first place, and first row to third place. So it will be 0 minus 1 and minus 2, and here we will have 8 9 10. Now we can proceed for elimination. We can take this pivot. Now we want to eliminate this guy as 0 and this guy as 0. So we will subtract the second row from the first. So the first row will be as it is. Subtract the first row from the second, so it will be 0, 9 minus 8 will be 1, 10 minus 8 will be 2, and this third row will be as it is because this is already 0 here. Now let's take this second pivot as this one, and now further apply the elimination and eliminate this guy. So we can put our first row as it is, second row as it is, and the third row we can add up, and here we will get the 0. So here also we will get the 0. So you see that we have the two pivots here. We cannot consider this as a pivot because it's a 0. So rank of this P plus Q is 2. Okay, let's look at this question. So we have given this matrix, right? And we have been asked the which statement is true about the eigenvalue and the eigenvector. So this is the question. Of an eigenvalue 3 has the multiplicity 2 and only one independent eigenvector exists. Similarly, P have two independent eigenvector, has the 3 eigenvalue 3 and the multiplicity of 2, and no independent eigenvector exists, and eigenvalues are 3 minus 3 and 2 independent eigenvector exist. So overall we will have to find the eigenvalue and the eigenvector, and we will have to look at how many eigenvalues are there and what's the multiplicity of there, and how many independent eigenvectors do exist. So we can do that easy, right? So to find the eigenvalue, we will have to take the determinant of 5 minus lambda minus 1, 4, 1 minus lambda. So that will give you the characteristic equation. So it will be 5 minus lambda times 1 minus lambda plus 4 is equal to 0. So that will give you lambda square and minus 6 lambda plus overall it will be 9 is equal to 0. I think lambda square 5 minus, okay, so this is correct. So from here you will get that lambda minus 3 whole square is equal to 0, right? Because lambda square plus 6 minus 6 lambda plus 9. Okay, so you see that we get the lambda 1 is equal to lambda 2 is equal to 3. So we have only one eigen value, and the second eigenvalue is the same as the first. So the multiplicity of the eigenvalue would be, the multiplicity of this eigenvalue 3 would be 2, right? And corresponding to this eigenvalue 3, so lambda 1 is equal to 3, we will get some eigenvector. And for this lambda is equal to 3, we will get some eigenvector. Both these eigenvector will be same. So what we can say that these two eigenvector will be dependent. So we will have only one eigenvector that will be independent, because the second eigenvector is going to be dependent on this, or you can say it is going to be the same as this first eigenvector. Okay, so the correct answer for this, the eigenvalue 3 has the multiplicity 2 and only one independent eigenvector exists.
So this question is from CE Civil Engineering, and year is 2017. We have given this matrix P is the inverse of matrix Q. So P is the inverse of matrix Q. So we can write P is equals to inverse of matrix Q. So P is equals to inverse of matrix Q, right? So we will have to check, and this in the question it is given that this I is denotes the identity matrix. So we will have to check that which of the option is correct, right? So with this relation we know that so P, so let's check this first one. So P times Q is equal to I. So we can write P as Q inverse. So Q inverse Q will be I. So this is correct. Also, if we check this one, Q P, right? So we can write P as Q inverse. So Q times Q inverse, that will be also I. So you take either way, that is going to be identity matrix. So the correct answer for that is C.
So the next question is again from CE Civil Engineering 2017, and it's a kind of multiplication question. We have given this A and with B, and but we have been asked that A transpose B. So we can do that, right? We can write A transpose A as 1, 5, and here we have given 6, 2, and B transpose would be 3, 8, and 7, 4. We can carry out this multiplication. So it will be 3 times 1, that is 3, and plus 7 times 5, that is 35, and here we will have 8 plus 20, and here we will have 18 plus 14, and here we will have 48 plus 8, right? And we can do the addition. So we will get 38, 28, and here we will have 40, 32, right? And here we will have 56. So this is the correct answer for this. So this question is from again Civil Engineering 2017, and we have given the system of equation. We have been asked that what would be the characteristic equation, right? So we have given this linear equation. First of all, we will have to translate this equation in the matrix form, that is Ax is equal to b, and from here we will have to find the characteristic equation by taking the by taking the determinant of a minus lambda I, right? And here C1 and C2 are the constant. So let's do that. So we can write in terms of this equation as a matrix form, right? So that would be 3, 2, and 4, 1, right? So that is matrix A, and this will be our vector x1 and x2, and here we will have C1 and C2, right? So this is A, x is equals to B, right? So we get the matrix A. Now we can take to find the characteristic equation, we will have to take the determinant of, so basically we will have to find A minus lambda I, right? So that would be equals to 0. So that will be 3 minus lambda 2 and 4, 1 minus lambda, the determinant will be equals to 0. And from here what we can do, 3 minus lambda into 1 minus lambda minus 8 is equals to 0. So from here we are going to get 3 minus 3 lambda and minus lambda plus lambda square plus 8 is equals to 0. So from here lambda square minus 4 lambda plus 11 is equals to 0. Okay, here it is minus, right? So we will have minus 5. So lambda square minus 4 lambda minus 5, lambda square minus 4 lambda. Okay, so this question is from ME Mechanical Engineering 2017. So this is a conceptual question. So we have given this matrix A, and corresponding to and this matrix have two eigenvalues, that is lambda 1 and lambda 2, and the corresponding eigenvectors we have given the eigenvector of this lambda 1 is this x1, and the eigenvector corresponding to eigenvalue lambda 2 is this one. So this ensures that we will be having two eigenvectors, right? Or this ensures that we will be having two different eigenvalue, right? Then what we have been asked that what would be the x transpose, x1 transpose x2, right? So x1 is here your eigenvector, and this x2 is the second eigenvector, right? So you see that if you look at this matrix, that this matrix is a symmetric matrix, right? And if it is a symmetric matrix and you are getting two different eigen value, then and how I'm saying that this we are getting two different eigenvalues, because you see that this x1 and x2 is going to be different anyhow by looking at this, right? So these two, we are going to get this two different eigenvalue, and if we have two different eigenvalue and we have given this matrix A is symmetric matrix, then it is 100% sure that the eigenvector we will get would be orthonormal. So this x1 would be perpendicular to this x2, or you can say that dot product between x1 and x2 would be 0, or you can say that x1 transpose x2 is equal to 0. The correct answer for this is 0. So you do not have to calculate all these things, right? So this is from ME and this is the easy question. So determinant is given of 2 by 2 matrix is 50. So we can say that lambda 1 into lambda 2 is equal to 50. The product of the eigenvalue is equal to the determinant of matrix M, right? And we have given this one lambda 1. So we can find lambda 2, that would be 5. And what we have to find is the other eigenvalue. So that is the other eigenvalue, that is the 5. So the correct answer for this is 5, right? Okay, let's move to next question. Next question is from Mechanical in 2017. We have given this matrix P. What we have to find is the product of eigenvalue of P. So that is nothing but the determinant of this P. So we can easily find the determinant of P. So it will be 2 times 3 minus 6 minus 4, and we will left with minus 2, right? So it will be minus 6 and plus 8. So 6 minus 8 minus 6 is 2. The correct answer for this is option B. Okay, now let's look at next question. This question is from EE 2017. This question is AG. So we have given this matrix. We have to find the eigenvalue of this matrix. Matrices are. So you can go by option directly, right? Because it's good to go by option because we know that the trace of this matrix is 4. That means minus 4. That means sum should be minus 4, right? So if you look at this, here sum is plus 4, here sum is plus 5, here sum is minus 5, and here sum is minus 4. So according to that, the correct answer for this question is option A. Okay, let's look at this question is from EE and 2017. We have given this matrix A, and what we have been told about this matrix A, that it has a 3 distinct eigen vector. So this is important point to note, and one of its eigen vector is given, right? So we will have to find that what will be the other eigen vector. We have given this option. Now this is very important, right? Whenever this information is given, that 3 distinct eigen vector, or if it is 2 by 2 matrix, 2 distinct eigen vector, then go back and look at your matrix, and if you observe this matrix is nothing but the across the diagonal. If you see that this matrix is symmetric, right? The elements are equal, and this one equal, this one and this one equal. So this is nothing but the symmetric matrix. And if you know that the symmetric matrix have the eigenvalue that are orthogonal, right? They are perpendicular to each other. So if one of the eigenvector is given, then that means if you take the dot product of these options in given option, then that would be 0. So let's start and take the dot product. So let's take the transpose of this and take, or you can directly take the dot product, right? So you can take the dot product. It will be 1 times 0, 0, 0 times 0, 0, and 1 times minus 1, that will not, that is out of option. Then 1 minus 1, that will be also out of option. And here this one will be 1 into 1, that is 1 plus 0, and 1 into minus 1, that will be 1 minus 1, right? So this will cancel out, and the dot product with this option C would be 0. And let's try with this D. So dot product, you will take 1, so that will be non-zero. So the correct answer for this option C, right? So there is a very important property regarding this symmetric matrix. So you will have to keep that in mind, that if a matrix is given symmetric matrix, and if it is 3 by 3, then if it has all the 3 eigenvectors that are independent, then you can say that all the eigenvectors will be orthonormal to each other, right? Okay, let's look at next question. So this question is from EC 2017. We have given this matrix M. We have to find the rank of this matrix. So what we can do, we can apply the elimination, and we can count the number of pivots that will be the rank of the matrix. So let's do that. So we have given this matrix 5, 10, 10, 1, 0, 2, and 3, 6, 6. Take this as a pivot, apply the elimination to eliminate these two guys. So we will have 5, 10, 10, and here we will have 0, 0 anyhow, and here we will have 0 minus so 0 minus 10 into the multiplier would be 1 by 5. So minus 2, and here we will have 2 minus 10 into 1 divided by 5. So here we will have 0, and here we will have 6 minus now here the multiplier would be 3 divided by 5. So here we will have 6 minus 10 into 3 divided by 5. So it will be 0, and here we will have 6 minus 10 into 3 divided by 5. So again it will be 0, right? So now we can take this as pivot, but already this is 0. So we have two pivot columns. So we can say the rank of this matrix is 2. So the correct answer is 2. So this question is from EC 2017. We have given this matrix. We have to find the rank of this matrix. So let's proceed by elimination. We are going to make this guy 0. So let me write it down, all the remaining rows that have no effects on it. -1 0 0. This is going to be 0 by adding those two rows, and this is going to be -1, and here it will be 0, and here we will have 0, and here we will have 1, and everything is going to be remain as it is, right? Now we cannot take this as pivot, right, because this is 0. Now we can do row exchange, right? So if we do that, what will happen? Let me do that. So the second row is going to be at first place, so it will be 0 1 -1 0 0, and the second row will be at the third place, 1 -1 0, right? Now we have already taken this pivot. Now we can take this pivot and we can eliminate this. So if we do that, here it will be 0, right, and here we will have -1, and here we will have 0, and here we will have 1. That is good. Now we can take this as pivot and we can eliminate this. So here we will have 0, and okay, let me see what was there. So we are adding, right? So that will add up and it will be 0. So here we will have 0, and here we are going to have -1, and here 1 is good. Now we can take this as pivot and we can eliminate this. So here we are going to have 0. So we are adding it, right? So, and here we will have 0, right? So you see that how many columns are the pivot columns. So this one, this one, this one, and this one. So this the rank of this matrix will be 1 2 3 4. So 4. So the rank of this matrix is 4. Okay, now let's look a few more questions. This question is from Instrumentation Branch 2017, and question given is that if V is a non-zero vector of dimension 3 by 1, then the matrix A, that is V into V transpose, has the rank. So we have asked about the rank of this V or V transpose matrix, that we are calling it A, and what we have given about this V, that is it is a vector of with the 3 row and 1 column, so 3 by 1, right? So so you can look anyway. So rank of this V into V transpose would be less than equals to the rank of V or V transpose. So that way you will look and you will find, even if it's a 3 by 1, so you are going to get anyhow one pivot in the V and also in the V transpose. So the rank would be 1, right? That is the one way to look at this. And another way you can look at this, so V into V transpose, right? So you can take A, B, C, and that is V, and V transpose would be A, B, C, right? Do the multiplication. So it would be A times A times B, A times C, B times A, B times B, B times C, C times A, C times B, C times C, right? So you can write this matrix as a linear combination, right? So you see that you can write this A, because here in this column A you can take it out, A, B, C, and plus here in this column you can take B, so A, B, C, and plus here you can take A, B, C. So you see that these vectors are the same, and you are taking, so it is the condition something like that. You can say 2 2 2 2 2 2 and 2 2 2, and you are taking some linear combination of this, right? So you have these two vectors that depends on the first vector. So you ultimately you will have one vector that is independent, and other two vectors are depending on the first vector. So the correct answer for this is 1. Okay, let's move to next question. This question is from 2017 Instrumentation Branch. We have given this figure, and this figure is the mirror image. So this figure is the mirror image of this figure. This is the original one, and this is the mirror image, and this is what we are considering the mirror, right? So we have to find the coordinate of the transformation matrix that maps this figure ABC to this A1 B1 C1. So what matrix will transform this the coordinate transformation matrix that maps ABC to A1 B1 C1? So if you observe the coordinates of this ABC in the original figure, that are all positive, so maybe you can take it as if you have to represent this vector A, then it would be some XA, X, Y, B. It will have some X coordinate and Y coordinate. Similarly for B also, right? XB and YB, and similarly for C, XC and YC, right? And this was the, so you can put it as in a matrix, maybe XP, YB, XC, YC. And if you look at the mirror image, if you observe the coordinates, then if you look at the changes, then the X is still positive and the changes are in the Y coordinate for all the A1, B1 and C1. So XB and YB and XC minus of YC, right? So what matrix will transform this matrix to this matrix? So this is easy. You see that the first row of this matrix is as it is, right? So what you are going to do, you are going to apply some identity matrix, kind of identity matrix, and the first row is same as it is the first row of the original, is as it is the first row of this mirror image. So we are going to preserve the first row and nothing for the, and you see that the second row of this matrix is the minus times of this. So we are going to do nothing with the first row at this time, and that will be minus times of. So now you do the multiplication, then you will get this, right? So matrix is nothing but matrix multiplication is nothing but the transformation of matrix. So the correct answer for this would be option D. This question is from again instrumentation, and we have given this matrix A, and we have to find the eigenvalue of this matrix, right? If you see that we have also the complex eigenvalue, so let's go by regular method that we used to do, that determinant of A minus lambda I is equal to 0. So if we do that, if we take the determinant, that will be 1 minus lambda times 5 minus lambda square and plus 36 equal to 0. That is what we will get, right? And from here what we can say that 1 minus lambda into lambda square plus 10 lambda, sorry, minus 10 lambda, and plus here we will have 25 and 36, that is 61, right? Okay, so we will have to factor it out. So it is going to be minus b plus minus root over b square minus 4 into a into c, that is 61, divided by 2a, that is 1. So 100 minus, so it will be 241, right? 244. And if here we will have 4 and 144 square root would be 12. So 10 plus minus 12j divided by 2, and here we will have 5 plus minus 6j, right? So one eigenvalue is 1, lambda 1 is equals to 1, that is real, and the 2 are the complex one, that is 5 plus minus 6j. So the correct answer is C. This question is from Computer Science 2016 year, and eigenvalue of matrix given 1 to 4. Eigenvalue of matrix A is given 1 to 4. The determinant of A inverse transpose. So we have to find the determinant of this matrix, right? So this is a easy question. So what would be the determinant of this A? That will be the product of this eigenvalue, that is 1 into 2 into 4, that is A, right? Then what will be the determinant of A inverse? That would be 1 divided by determinant of A. So determinant of A is 8, so determinant of A inverse would be 1 divided by 8. So that is the answer. So this question is from CSC 2016. What we have given is that the two eigenvalue of 3 by 3 real matrix P are 2 plus root under minus 1 and 3. The determinant of P is. So you see that this one is a complex. So we can write 2 plus j, right? So if one of the root is 2 plus j, then the other would be the conjugate of this. So 2 minus j. Now we have to find the determinant, and one of the eigenvalues is 3 also. So we have got 3 eigenvalue. We have to find the determinant. What we can do? We can do the product. So 3 into 2 plus j into 2 minus j. So that will be the determinant of this P. So that will be 3 into 4 plus 1, that is 5 into 3, that is 15. So 15 is the correct answer for this. Okay, this question is from CSC, Computer Science 2016 year. Okay, now let's look at this question. We have given this system of equation, and what we have been asked that the system is consistent if ABC satisfies the condition. We will have to find the condition, and at what condition the system will have the solution. So we can proceed by writing the augmented form of this matrix. So So the main goal is to convert this matrix to upper triangular, and after that you can apply the back substitution, and that will give you the condition that at what condition, for what condition of ABC you will get the solution. Now let's take this as a pivot and apply the elimination. Try to eliminate these two. So we will have first 2, and here we will have 0, and here we will have 3 minus 4, that is minus 1. Here we will have 3 plus 6, that is 9, and here we will have 0, and here we will have 9 minus 10, that is minus 1, 6 plus 15, sorry, minus 6 plus 15, that would be 9. So what we have done here is b minus 2a, right? And here what we have done is c minus 5a, correct? Now we can pick this as pivot and apply the elimination and eliminate this one. 2 minus 3, 0 minus 1, 9, and what we are going to do, we are going to subtract, so it will be 0, 9 minus 9, 0, a, b minus 2a, and what we have done here is c minus 5a minus, we have subtracted the second row, right? So minus 2 plus 2a. Now you are going to apply the back substitution here, and to have the solution, this should be equal to 0 because the left hand side is 0. So c minus 5a minus b plus 2a is equal to 0. So minus 3a minus b plus c is equal to 0. That is equivalent to 3a plus b minus c is equal to 0. So the correct answer for this is B. Okay, so let's look at this question from Computer Science year 2016. So what we have given is, if the entries of each column of a square matrix M add up to 1, then the eigenvalue of M is. So this complete thing is a property of a special kind of matrix, that special matrix named as Markov matrix. So Markov matrix. So the point is that this matrix have all entries greater than equals to 0, then we will call it positive Markov. And second thing is that all column add up to 1. So let me give you an example. 0.1, 0.2 and 0.7, and 0.01, 0.99, so this one is 0, 0.3, 0.3 and 0.4. So decimal is there, right? So this is the example of Markov matrix. If you add up column, it will 1. If you add up 1, it will add up 1. Now the next thing is that lambda is equals to 1 is an eigenvalue of this matrix, right? And the fourth thing is that all the eigenvalue have magnitude less than 1, right? So lambda is equals to 1 is an eigenvalue, that is the one thing, and the all other eigenvalue have the magnitude less than 1. Right, so the eigenvalue of M is 1. So 1 is the correct answer. You can look at the properties of this Markov matrix. You will have more idea. So this question is from 2016 PI branch. I don't know what the PI branch, but we have the question here. The number of solution of the simultaneous algebraic equation y is equals to this and y is equals to this is. So you can look at this and you can say that what would be the solution. We will have 0 solution, 1 solution, 2 or infinite solution. So we can write y is equals to 3x plus 3 as minus of 3x plus y is equal to 3, right? Yes, and similarly we can write this equation as minus of 3x plus y is equal to 5. We can write the matrix equation, so that is 3 minus 3 1 1 xy is equal to 3 5. Now we can apply the elimination to find the solution. So minus 3 1, this would be 0 and this will be also 0, right? And so here we will have 3, and here we are going to have 5 minus 3, that is 2. So you see that here left hand side is 0 and right hand side is 2. So 0 is equals to 2. No, it can't be possible. So this system has no solution. So 0 is the correct answer. So next question we have again from 2016 PI, and we have to find the eigenvalue of this matrix. We have given these options, so let's do that. So to find the eigenvalue, we will find the determinant of 0 minus lambda, that is lambda minus lambda 1 and minus 1, and 0 minus lambda, that is minus lambda, that should be equal to 0. So lambda square plus 1 should be equal to 0. So from here lambda is equals to plus minus I. So the correct answer is A. So this question is from 2016 ME mechanical, and here we have to find we have given this matrix, and we have to find the number of linear independent eigenvector. So how many eigenvector that are linearly independent? So for that we will have to first find the eigenvalue, right? And corresponding to that we will have the eigenvector. So let's do that. We can find the eigenvector, right? So in this case we will have eigenvector lambda 1 is equal to 2, and lambda 2 is equal to 2, and lambda 3 is equal to 3, right? Because this is upper triangular matrix. So even if you go, so that is the eigenvalue, right? And for corresponding to these two we will have the two eigenvector that will be same, right? And for this we will have the different eigenvector. So out of 3 we will have 2 linearly independent eigenvector. So the correct answer for this is 2. So we have this question from 2016 ME, and question is a real square matrix A is called skew symmetric matrix if A transpose is equal to A transpose is equal to A inverse, A transpose is equal to minus A transpose is equal to A plus A inverse. So if A is skew symmetric matrix, then it should satisfy this condition, that is A transpose is equal to minus of A. So the correct answer for this is C. Okay, now we have this question from 2016 mechanical branch. So the condition for which eigenvalue of the matrix is positive. So we will have to find that what condition for K we will have the eigenvalue of this matrix is positive. So the trace of matrix is 2 plus K, right? If eigenvalues are positive, then the trace is also going to be positive. So that means it should be equal to, it should be greater than 0, right? That is the one condition. And the second condition is that we need to have 2k minus 1. This should also, the product of these eigenvalue should be greater than 0, right? So from here what we can say that k is greater than minus 2, and from here what we can say that k is greater than 1 divided by 2. So if you take the common part, so that would be from minus 1 by 2. So k is greater than 1 by 2 is the correct one. So this question is from ME 2016. So here we will have given this matrix equation that Ax is equals to B. Now we will have to find the solution of this, right? So this x and y we will have to find. So what we can do is you can solve this equation, right, by putting the matrix in augmented form. Then we can proceed for the elimination. So it would be 2 5 and here we will have 0 and the multiplier is minus 4 divided by 2, so that is minus 2, right? So 10, so 3 minus, that is plus 10. Here we will have 13 and here we have 2 and minus 30 minus 2 times minus 2, so that is 4 and minus 30, so it will be minus 26, right? And now you can do the back substitution from here, that is 13y is equals to minus 26, so y is equals to minus 2 and here 2 times of x1 plus 5 times of y, that is minus 10, so here we will have minus 10 is equal to 2, so from here x1 is equals to 12 divided by 6, 12 divided by 2, that is 6, so correct answer for this is 6 minus 2. Okay, so this question is from 2016 instrumentation and we have given this matrix A whose eigenvalues are given that 1 minus 1 and 3. Then the trace of this matrix is, I think this question is same that they have copied in the sample paper of DA, right? So there I have already solved, but let's do it one more time. So trace of this AQ minus 3a square, right? That will be equal to trace of AQ minus that trace of 3a square, right? So the concept behind this is that you can diagonalize matrix and you can find the trace of these all AQ and a square, right? So here what we have to find is that what would be the, when we do the diagonalization of this AQ, then what would be the diagonal element of this A cube, right? So we have given this matrix, right, the eigenvalue of this matrix. So for AQ the diagonal element would be 1, the minus 1 and 27, and for this A square it would be 1 1 9, but we will have to look for the 3a, so 3 will get multiplied with every element, so it would be 3 3 and 27, right? Now we will have to take this difference, right? So we will have minus 2 and 1 minus 3, that is minus 4, and here we will have 0. Now we will have to add up these because we are at the end we will have to find the trace, the sum of the diagonal element, so that is minus 6. So the correct answer for it is minus 6. So this question is from EE 2016. What we have given is 3 by 3 matrix P such that PQ is equals to P, then eigenvalue of PR. So from here we can write PQ minus P is equal to 0, and if lambda are the eigenvalues, then we can write lambda cube minus lambda is equals to 0, and that would be lambda square minus 1 is equal to 0, and from here lambda is equals to 0 and lambda is equals to plus minus 1, so 0 1 and minus 1. The D is the correct. This question is from EE 2016. Let A be 3 by 3 real matrix which rank 2. So this matrix have rank 2. Which of the following statements is true? Rank of A transpose is less than 2. If A has rank 2, then A transpose should have also rank 2. So less than 2, this statement is false. Rank of A transpose A is equal to 2. Yes. So because rank of this A transpose A should be less, that should be because both are of the same, so that should be less than equal to rank of A, and both are the same, so it would be equal to 2, right? If both is different matrices, let's suppose A and B are two different matrices, then that time we should need to take care of which one have the minimum rank, right? So this is the correct rank of A transpose A is greater than 2. No, this cannot be correct because rank of A is 2, so it can't be greater than 2. Rank of A transpose A can be any number. No, so the correct answer for this is option B. Okay, so this question is from EE 2016. Eigenvalues of 2 by 2 matrix is given 1 minus 2, and eigenvector corresponding to 1 is x1 and corresponding to minus 2 is minus x2. Eigenvalue and eigenvector of matrix this would be. So we have been asked that what would be the eigenvalue and eigenvector of this matrix, right? So let's, so how we can find the eigenvalue of this matrix? So it would be, so the concept behind this kind of problem is the diagonalization, right? If you have the picture of diagonalization, then you would know that the A square, when you diagonalize it, it will have the this diagonal matrix that contains the eigen value of this A square would be uh, let's call this some lambda, and this would be a diagonal matrix with the diagonal position would have the value that would be the eigenvalue of this A square, and we have given this A eigenvalue of A. So A is, for this matrix A square, the eigenvalue would be 1 and 4, right? So similarly we can find the eigenvalue of this 3A, and that is going to be 3 minus 6, right? And this 4I, that would be 4 and 4, right? And we have to minus, subtract this and add up this. So the ultimately we will have this matrix that will have the eigenvalue that would be 3 4 plus 5 minus 3, that is 2, and 4 plus 6 is 10, and plus 4 is 14. So this would have the eigenvalue that is 2 and 14. So this can't be answered, this can't be answered. We are left with A and B, right? And can you tell me that the eigenvector of this matrix is also going to be the same as the eigenvector of this A, right? Can you tell me why? Let me know. For the correct answer for this is A. Okay, so let's look at this question. EE 2016. Consider 3 by 3 matrix with every element being equal to 1. Its only non-zero eigenvalue is. So we have to find its only non-zero eigenvalue, right? So let me take every 3 by 3 matrix that have every element 1 1 1 1, and A times lambda I would be, so to find this eigenvalue we will have to do this. So we can do that, and it will be 1 minus lambda 1 1, and 1 1 minus lambda 1 1 1 1 minus lambda. And now we will have to take the determinant of this, right? So determinant of this should be equal to 0. So 1 minus lambda times 1 minus lambda square minus 1, right? Minus 1, and 1 minus lambda minus 1 plus 1, and here we will have 1 minus 1 plus lambda. and this would equal to 0. So here we will have 1 minus lambda to the power cube and minus 1 plus lambda plus that will be lambda, and this will be plus lambda is equal to 0, right? So 1 minus lambda minus 1 plus 3 lambda is equal to 0, right? So here we can take lambda 0, then okay, so if we take lambda equals to 0, then obviously that is going to be 1 minus 1, that would be 0, but we have to take the non-zero eigenvalue, right? So maybe we can try with 1, so it will be not equals to 0. We can try with 2, so 2 minus 1, that is minus 1, and minus 1 minus 1 minus 2. We can try with 3, so 3 minus 1, that is 8 minus 8 minus 1 and plus 3 into 3, that is 9, so 8, that will be equal to 0. So lambda is equal to 3 is the non-zero eigenvalue, only non-zero eigenvalue, other will be 0. So the correct answer for this is 3. This question is from EC 2016, and here if you see we have given these vectors E1, E2 and E3, and these vectors are forming a orthogonal basis, right? So they are the basis of some dimension R cube, right? That means these three vectors can give you a complete 3D space if you take any combination of these three vectors, right? So by taking any combination you can reach to any point in this R cube. That is what it means. So the vector u that belongs to R cube can be expressed as, so basically, so we have given this vector u, right? And this vector u also belongs to this space R cube, right? That means you can take some combination of this vector, this basis vector, and you can reach to this u, right? And what we have been asked, that what combination you will take to reach to this vector, that is what we have to find. So what combination of E1, what combination of E2, what combination of E3. So this is nothing but this is equivalent to solving a matrix equation. So you can form a matrix using this E1, E2 and E3, right? You can write the columns of as a columns of this matrix. And so what combination, that let's call it maybe u1, u2, u3 or anything else, x, y, z, will give you this matrix u, that is 4, 3 minus 3. So this is what we have to find. So we can apply the elimination. So we can take this as a pivot, and first of all you have to write the augmented matrix, so that you know. So this will be 1, 0, minus 2, and here it will be 4, here 0, 1, 0, and here it will be 3. We can make this 0 by multiplying the first row with the 2 and subtracting it from the third. So here it will be 0, and here it will be 1 minus 4. So 1 plus 4, that is 5, and here we will have minus 3 and minus 8, that is minus 11, right? Now you see that now you can do the back substitution. So you will get 5, z is equals to minus 11, so z is equals to minus 11 divided by 5, and here from here you will get y is equals to 3, and from here you will get x minus 2 into, so 11 divided by 5 is equal to 4, so that should be x is equal to 4 minus 22 divided by 5, that is minus 2 divided by 5. So this is what you have been asked. So x is, so overall point is that now you can write this as a linear combination of these columns. What does it mean? That you can take the minus 2 by 5 times of e1 and plus 3 times of e2 and times of e1 and plus 3 times of this one and minus 11 times of this row, this column, and minus 11 times of 5 of this e3, and that will give you this matrix, this vector u. So the correct answer for this is, so this can't be answer, this can't be, because here minus minus now, so D is the correct answer. Easy 2016, where matrix A is given and here x is unknown. These are the sigma and this is omega. Eigenvalue of A are sorry, this and this. The x is equal to, so we have to find this x, right? So what we can do is, if we add up, so this x is involved, right? So we will have to take anyhow the determinant of this matrix. So let's do that. So determinant of this matrix would be sigma square minus omega x, and that should be equal to the product of these eigenvalue, and that would be sigma square and minus of j omega sigma and plus of j omega sigma, or what I am doing, so that would be anyhow equal to sigma square plus omega square, right? That will be equal to sigma square plus omega square, right? And from here we can say that will get cancel, and what we have to find is x. So x would be omega square divided by minus omega, that is minus omega. So x is minus omega, right? So the correct answer for this is D, right? Okay, now let's look at more questions. Okay, so in this question we have given this matrix A, and here if you see x is there, and we have been asked that the value of x for which the matrix has 0 as an eigenvalue. So if there is any eigenvalue that is 0, then the product of eigenvalue is going to be 0. That means determinant of the matrix A is going to be 0, because that determinant is equal to the product of the eigenvalue. So we can calculate this by taking the determinant of this matrix. So let's do that. So we will take 3, and that would be minus 63 plus 7x minus 2, and that would be minus 81 plus 9x and minus minus plus, that would be 78, and plus 4 minus 36 plus 42, that would be equal to 0. And from here, okay, so here I think I have left one more term, that is plus 52, right? So now here we will have 11 minus 11, that is minus 33 plus 21x, and here we will have minus 3 and minus 2, that would be plus 6, and this is 9x, so minus 18x, and here 4 and 6, and 6 times 4, that is 24, equal to 0. Now 24 plus 6 is 30, and minus 33, that is 3, and so 3 would be there on right hand side, and 21, that is 3x. So x is equal to 1 is the answer for this. So this question is from EC 2016, and we have given this matrix A, and what we will have to find is the and we have also given this determinant of A is 100 and trace of A is 14. We have to find this absolute value of this, the difference of the A and B. So A is, where is A? A is here and B is here. So you can take the determinant and you can find this one is easy question. So what I can do, maybe I can convert this into upper triangular matrix, because all these are 0 here. I will have to make only this 0. So let's make it 0, and that is going to be as it is 5. There will be no effect. There will be some changes on here, but there will be no effect on happening the change, or whatever is changing is happening here. There would be no effect on our solution, because we have given this determinant of A is 100. So since it is the upper triangular matrix, right, then we can say that upper triangular, that means like this. So we can say that A times 5 into 2 into B, that is 10 into B, is equal to 100, and the trace is given A plus 7 plus B is equal to 14. So from here A into B is 10, and from here A plus B is equal to 7. So what number you multiply will give 10, and what number you will multiply give 7, that is 5 and 2, right? If you multiply, then it will be 10, and if you add, that will be 7, right? So A is 5 and B is 2. So A minus B would be 5 minus 2, that is 3. So 3 is the answer for this question. So this question is from 2016 AC. So we have given that m to the power 4 is identity matrix, and this m is not an identity matrix, even not m square and even not m cube. Then for any natural number k, m inverse equals to. So we have given this m to the power 4 is equals to identity, right? So what would be m to the power 8? That would be m4. I think the multiplication of these two would be m to the power 4, and it should again identity matrix, right? And so if we try to find the m inverse, then we can maybe multiply m inverse here and m inverse here. So what we are going to get is m inverse is equals to m to the power 7, right? So for k is equals to, it is 1 to the power 7 here. For k is equals to 6, k is a natural number, or what we can do, that m to the power 4 into m to the power 4 into m to the power 4, that is going to be identity matrix, right? So from here it will be m to the power 12, and if we try to find the inverse from here, that would be m to the power 11 is equals to m inverse. So for k is equals to 2, that is going to be m to the power 11, right? So I think this expression will satisfy the m inverse, because you see that here m inverse is equal to m to the power minus m to the power 7, right? And here m inverse. So this is the equation going to satisfy this condition. So correct answer is C. Okay, this question is from CS and 2015. So question is, if the following system has non-trivial solution, so some non-trivial solution exists for this system of equation, then it is asked that which one of this true, right? So okay, maybe we can write this system of equation as in matrix form. So P Q R and Q R P and R P Q times x y z, that would be equal to the 0 0 0, right? So or maybe we can write as a linear combination of P Q R plus y times of Q R P plus z times of R P Q, that would be equal to 0 0 0, right? And given the option, right, so okay, so if we, so the main point is that here on right hand side we should have this 0, right? So this q times p plus y times q, this z times r should be equal to 0. And for if okay, so I think we can take this xyz, if we try with this option A, then there is some linear combination that is giving 0, right? So here if we take x is equals to, according to this option 1, x is equals to 1 and y is equals to -1 and z is equals to 1, so we will have this equation, right? If we take this x is equals to 1, this one -1 and this one 1, right? So we will have p minus q plus z, sorry, p minus q plus r, and here we will have q plus minus r and plus p, and at the end r and minus p and plus q, right? And in option A we have given this 0, this one, right? So we got this one 0, but according to this condition, if we try to solve this, so p is equals to q, so we can take p is equals to q, so that okay, not, that will not get cancelled, but we can take q is equals to minus r. So even if we use this condition, right, so p is equals to q, let's take p is equals to q, so p minus r plus p, that would be 2p minus r, and p is equals to minus r, so p is equal to minus r, so that would be minus 2 r, so that is not going to be 0, right? Okay, so I think we will get 0 when, according to option, if you see that when if you pick this option C, right? Because you take x as 1, y as 1 and z as 1, then we have given that p, and if you take the linear combination, that would be 1 times p and 1 times q, so 1 times p plus q plus r, and the second would be again q plus r plus p, and third would be r plus p plus q, right? And if you see that this condition is given, that p plus q plus r equal to 0, and here also p plus q plus r, that is equal to 0, and here also p plus q plus r, that is equal to 0. So I think for x1, y1, z1, this equation will get satisfied according to this options. So the correct answer is option C. So this question is from CS 2015 and we have given this matrix and one of the eigenvalue is 1. The eigenvector corresponding to the eigenvalue 1 are. So corresponding to 1 eigenvalue you will have to find the eigenvector. So to find the eigenvector what you will look for lambda is equals to 1, right? For lambda is equals to 1 you will have to find the null space of this matrix. The null space of this matrix, right? So how we are going to do, first of all let's find this matrix, right? So the null space of this matrix, maybe xyz here. So first of all find this matrix, right? So here lambda is equals to 1, so we can find easily. So it would be 1, that is 0, minus 1, 2, and 0, 0, 0, and here we will have 1, 2, and 0, right? And we will have to find the null space of this matrix, right? 0, 0, 0. So you see that this is 0, right? And ultimately you will have to get the 0, right? So minus 1 times x minus 1 times y and plus 2 times z. So what you will pick y, you are going to pick y is equal to minus y is equals to 2, right? Then this will get multiplied by 2 and will add up to this and z what you are going to pick 1, right? So if you pick z1 then it will be 2 and here it will be minus 2, that is going to add up and you will get this 0, right? And from the third row you pick x and y you have already, right? So 4 is there, so 2 times 2 4, for that you will pick x as minus 4, so x will be minus 4. So this is the solution for this system of equation, right? And this will be the your eigenvector corresponding to lambda is equals to 1. So the eigenvector is minus 4, 2 and 1. So the correct answer is B, right? And so we will have to find all the eigenvector. That is why we have taken the multiple that alpha belongs to some real number, right? And that if you multiply with this vector, that are still going to be the eigenvector of this, because that those two vectors are going to be in the same direction, right? If you take this vector a, or let's take this eigenvector x1, then if you multiply alpha times x1, that is going to be the same direction. So that the correct answer for this B. Let's move. So this question is the larger of two eigenvalue of this matrix. So which one would be the larger eigenvalue? So we can write this as lambda square minus 5 lambda plus, that would be minus 6, right? So minus 6 is equal to 0, and we can factor it out. 6 lambda plus lambda minus 6 is equal to 0, that is lambda minus 6. So from here we can get lambda is equal to 6 and minus 1, so larger than is 6, so correct 6. So this question is, if two columns of determinant are interchanged, then what will be the effect on the determinant, right? If you change the row or column, right? So maybe if two column we are changing this and this exchanging, or maybe with this, then determinant is going to be multiplied with this minus 1. So that was the question, and we have given 4 options, so that is the answer for this. Okay, so this question is from CE 2015. We have given this matrix A with the element Aij, and I is greater than 1, j is less than equals to n with n greater than 3, and the element are these, right? So if we take I is equals to 1 and j is equals to 1, then a11 would be 1. The rank of a is, right? First of all, just write the matrix, right? If we take I is equals to 1 and j is equals to 1, we will have here 1 into 1, that is 1, and again 1 into 2, 1 into 3, 1 into 4, right? Because I could be greater than 1 and j should be less than n and n should be greater than 3, so we can take it. And similarly, if we write the second row, then it would be 2 into 1, 2 into 2 4, 2 into 3 6, 2 into 8. So we have asked about the rank of a, right? So you see that this vector is going to be 2 times multiple of this, right? And this is going to be 3 times multiple of this, and this is going to be 4 times multiple. So here we will have only one independent vector, and other these columns are the multiple of this first column. So we will have in this case only one rank, so we will have this here pivot. Yes, because all these are the multiple, so one is the correct for this. Okay, next question is from C 2015. For what value of p the following set of equation will have no solution? So these are the set of equation. So we can write this matrix, this equation as a matrix equation, that is 2 3 and 3p augmented with 5 10, right? And we can apply the elimination, so that we can do 2 3 5. Here we will have 0, the multiplier is 3 divided by 2, so p minus 3 into 3 divided by 2, that is 2p minus 9 divided by 2, right? Yes, 2p minus 9 divided by 2. And here we will have 10, so 10 minus 5 into 3 divided by 2, so 20 minus 15 divided by 2, that is 5 divided by 2. Here it is 5 divided by 2. So what we have to find, that what value of p, we have no solution. So if we take p is equal to if we make this 0, right, so 2p minus 9 is equal to 0. So from here p is equals to 9 divided by 2. So if we take p is equals to 9 divided by 2, this is going to be 0, right? And on the left hand side this is 0, on the right hand side we have something, right? So 0 is not equals to 5 by 2, for p is equals to 9 by 2. So for p is equals to 9 by 2, we will have not solution. That means 4.5 is correct answer for this. Okay, let's look at this question. So this question is from IN 2015. Let A be n by n matrix with rank R, and rank R is from 0 to n, right? Then AX is equals to 0, have P independent solution. So P independent solution, where P is R, n minus R, and n plus R. So what does it mean AX is equals to 0 has P independent solution? So basically what we have been asked here, that how many bases are in the null space. So AX is equals to P has P independent solution. So P independent solution means how many bases will be in the null space, right? So, or you can say the dimension of the null space. So basically indirectly you can say that here we have to find the dimension of this null space. of matrix A, right? So we know that if the matrix have rank R, then the dimension of this null space would be n minus R, right? So this we will have n minus R basis in the solution space, right? And those n minus R vector will span the complete null space, right? So the correct for answer for this is C. So here we have question from 2015 double E. We have given that we have a set of 3 linear equation and 3 unknowns. That means when you will form a uh, matrix equation, then matrix would be of 3 by 3, right? A square matrix. We have given this statement. We will have to see that which statement is correct. So statement B, there is a unique solution. Okay, basically here you will have to see that if the first point is the determinant of the coefficient of matrix is non-zero. If it is non-zero, then we can say that this P will be equivalent to S, right? We both statement are same, right? If the matrix of determinant of matrix is non-zero of a square matrix, then there would be a unique solution and the determinant would be non-zero, right? The solution are linearly independent, that is also correct, and all eigenvalues of coefficient matrix are non-zero, that is also. So you can say that P is equals to Q. All these are equivalent statement, right? So, so that is what. So in this question, if the sum of the diagonal elements of 2 by 2 matrix is minus 6, then the maximum possible value of determinant of the matrix is. So sum of the diagonal elements given, that is sum of the eigenvalue, that is minus 6. So what would be the maximum possible value of the determinant? So maximum possible value of the product of the eigenvalue, right? So sum is given minus 6, right? So what could be the choice for this lambda 1, this lambda 2, such that sum is minus 6 and we should have the product maximum. So we can take lambda 1. If we have to make this sum, we can take, and lambda 1 maybe minus 6, lambda 2 0, or maybe minus 5 minus 1, minus 4 minus 2, minus 3 minus 3, and minus 2 minus 4, and minus 1 minus 5 at 0 and 6. And you see, we will have to take the maximum possible value of the determinant, right? So this product should be maximum. So either we can take these two positive, but we cannot take positive both of them. Why? Because the sum should be negative. So sum will be negative only when we will take both of these negative, or maybe one number with more negative than other. But if we take that kind of number, this will get negative, right? So overall point is that with the choice of positive negative, negative negative, negative positive, and positive positive, right, we cannot take this because the product will get negative number and we have to find the maximum possible, and we cannot take this also, right? And we are left with this one and this one. This we cannot take, this combination, because the sum is negative, so we are left with only this, and with this we have this combination. other is not possible, I think. No, with the negative only one. So out of this, the product of this will be maximum, right? Because this will be 5 times 1, 5, 8, 9. So the maximum possible value of determinant or the product of eigenvalue is 9. Okay, so here we have to find, we have given this matrix A and we have to find A, the determinant of this. We have to find the determinant of A transpose A inverse, right? So determinant of A transpose A inverse, we can write it as determinant of A transpose into determinant of A inverse, that is equal to determinant of A into 1 divided by determinant of A, right? Because the determinant of A inverse is 1 divided by A and determinant of A transpose is itself A, so it is going to be 1, right? So the correct answer for this C. Okay, so this question is from EC 2015 and the value of x for which the eigenvalue of this matrix are real. So there is the x and you see all the diagonal elements are real number and this one. So I think it's a Hermitian matrix, and so Hermitian matrix is a square matrix. So if it is a Hermitian matrix, then let's suppose that if we have some, so the basic properties of Hermitian matrix is that if you take the conjugate of this matrix, that would be 8 1 minus, so this diagonal element would be real number for this Hermitian matrix, and this would be 1 minus I and 1 plus I. So I am taking the conjugate, and now after taking the conjugate, take the transpose, that would be 8 1 plus I and here 1 minus I and 5. So these two are equal, then we can say that this matrix is the Hermitian matrix, right? And so the properties of this matrix is that the principal diagonal, that is this one, is going to be always real, right? And the non-diagonal element will be some complex number, right? And trace determinant of Hermitian matrix will be always real, and the trace would be also real. Okay, so the value of x would be 5 minus j. Our next question is from EC 2015. The value of p is such that the vector 1 to 3 is an eigenvector of this matrix H. So we will have to find the value of p, so that this is the eigenvector of this matrix. So according to the property of eigenvector, if x is the eigenvector, then it would be some multiple of x, right? So we can make use of this property, and what we can write is a is 4 p and 14 1 2 minus 4 2 1 0 times the eigenvector is 1 2 3, that would be equal to lambda times some eigenvalue times 1 2 3. Now we can carry out this multiplication, so that would be 4 plus 2 6 plus 6, that would be 12, and here we will have p plus 4 plus 3, that is 7, and here we will have 14 minus 8 plus 30, so 44 minus 8, that is 36, and that would be equal to lambda times 1 2 3. Okay, now these two are equal, right? So if you see that, if we look at this, these two, so maybe we can take 12 common. That means to make this 1 to 3, this would be p plus 7 would be equals to 24, right? Then if we take the 12 common, then we will have 1 2 3. So p is equal to 24 minus 7, that is 17. Okay, we have given this system of equation. Now we have to find the value of k, this for which the system of equation has infinite many solution. Okay, let's do that. Let's first write the augmented matrix. So 1 minus 2 3 and 1 minus 3 and 4 minus 2 4 and minus 6 minus 1 1 k. Now apply the eliminations. So here we'll have 1 minus 2 3, here we'll have 0 and minus 3 plus 2, right? So minus 1 and 4 minus 3 is 1 and here we will have 1 and 1 minus of minus 1, that is 2. Here we will have 0 and here 4 minus 2 0, 6, here we'll have 0, here k and k minus 2 into minus 1, so here we will have k minus 2. So if this system has infinite many solution, then this right hand side should be also 0, right? So k minus 2 should be 0 because left hand side is 0, so k should be equal to 0. And if it is true, then you can pick any x, because x times of 0 plus x y times of 0 plus z times of 0 is equal to 0. So you can pick x, y, z, anything that will satisfy this condition, right? So for k is equal to 0, the system of equation has infinite many solution.